a value 12. Second, 13. Third, 11. Then when we print it out, we just want to see these items. Okay. Then we have what they call growable lists. A growable list is that one that I say that it doesn't have a fixed size. It can have multiple numbers of things. For example, if you have a list called fruits, there are so many types of fruits, and you just have to make sure the list is growable so that you can always add new types of fruits. So let's see a code example for that one. For example, I can say number list. Numbers are infinite. Okay, they are infinite. They're not finite. They continue. You can't say that this is the maximum number that can ever exist. So for those ones, we use a growable list. And in this sample, I have a list with numbers. Okay. And then if we want to create a list using certain advanced syntax, we use this one, the right side of my screen. Yeah. Creating an empty list first. But here, instead of putting the value 3, compiler that we want you to give us an empty list that later on can be able to accommodate boundless numbers of items. So here we add the number 12 and 13. But remember, we have to specify the data type when we're using such syntax. Yeah, so we're just creating lists of items, and we know that lists hold values of the same types. So there are some list properties that enable us to play around with lists. For example, if I want to find the first item that is in a list, I can say the list name dot first. Or if I want to know if a list is empty, I can say list dot is empty. So this one will return a value true if the list is empty, if it has no elements. So if I also want to know if the list is not empty, I can use the words is not empty. And trust me, we are going to see this when we're doing our DAT programming. Okay. And then also for the length, this is also something very common. You want to know how many items have been returned, let's say, from a database in this list. So we use list.length to know a number of items that have been returned. And then for this one returns the last item in a list. Okay. If I want to know the number if I've been adding people to, let's say, a list of students, but I want to know the last person on that list. So I can just say the list name dot last, and it returns for us the last item on that list. Okay. Then reversed. This one here contains when you let's say you have a list of items, let's say integers, and you put 1, 2, 3, 4. So when you use that reversed, it will reverse it. You'll have 4, 3, 2, 1. Okay. And then this one here also, it checks whether a list has only one item. So if you use it on a list that has more than one item, you get an error. Okay. And we shall learn how to handle errors when we start Flutter development. Yeah. So on top of these actions are not really used to manipulate lists a lot. These ones just tell you about what a list has. Okay. But then when we really want to manipulate lists, we have list operations. For example, in order to add an item into a list or insert, there are certain functionalities we can follow to insert items. Then, if we want to update certain items in a list, okay, we also use certain functionalities, certain methods that we can use to update those items. And then sometimes there are items that are undesirable in a list, so we need to remove them. So we use those methods for removing those items. Okay. So here we look at an example of how to insert an element into a list. Okay. So when we say mutable lists, when you hear the word mutable in programming, it means something that can be changed. Okay. Something that can be changed. So a mutable list is a list that can be modified. It can be changed. For example, in this code snippet, we have a list L which has items 1, 2, 3. So we want to add 12 to this list. So when we print this, definitely it will give us results 1, 2, 3, and 12. Okay. And then there's this one. If you want to add more than one item to a list, not adding one at a go, we use the list.addAll method. Okay. So this one will add, these items 12, 13 to the list that already exists, which is 1, 2, 3 list items. So when we print, we shall have all those methods. And then there is insert and insert all. Okay, so that supports adding elements at specific positions in a list. Okay, sometimes you don't want to just insert, because when you use insert, if you use the others for adding, it will add those items at the end of a list. But supposing you want to add these items to the top of a list, for example, you have a leaderboard, you have a program that shows the best performing, let's say, football teams, okay, in a week. Okay, so there's always going to be a method that helps you update. Okay, if let's say some team has been beaten from position 1, is now on position 3, you'll use such methods to say, okay, at index 0, remove that team, put it on this index, then you pick the one that is in this current index 3 and put it at index 0. Okay, so these are the methods that help programmers achieve such functionalities. Okay, so yes, when I explain using real world examples like this, you tend to see what we actually use these methods for. So those are all lists. We see lists of items everywhere. Okay. Yeah. So let's see an example of insert. So here I've made sure I include the sample output. So here I say if I have a list 1 with 1, 2, 3, I want to insert the value 4. Okay. At index 0. Okay. So it will give us this output when we print it out. Okay. The first item will now be 4. Then followed by the rest of the originally existing items. Okay, so this is what list.insert does. And then what if I have multiple values that I want to insert? Okay, so if I have an existing list, 1, 2, 3, now I want to insert these other values at index 0. So notice the difference. Insert, singular. Insert all, inserts a list of other values into an existing list. So you can look at the output here. At index 0, we are going to have 120, 130. Remember, not all these values are going into the first index. We are simply telling it that replace these two values starting from index 0. Okay, so index 0 is now going to have 120. Then index 1, 130. Index 3, 1. Index 4, 2. And so on. So, that was for inserting. What if we want to actually update something? Okay, updating the index. Then there is that allows modifying the value of an item in a list. In other words, one can rewrite the value of a list item. Okay. So here is a code example. When we have a list L with items 1, 2, 3, and we want to update the value that is at index 0 to 1, 2, 3, this is what we do. We say L squared bracket 0. We now want the new value to be 1, 2, 3. Now when you print, remember, you see that 1 is no longer there, and the new value at index 0 is 1, 2, 3. Yes, so this is what we do when you're updating by use of an index. Then okay, so when we say list L here has values 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have a print statement that simply prints out what this current list is items. So the value of the list before replacing is here. So this is just to make sure it shows you what has changed. And then the next code we have tells us that we want to replace items that are from index 0 to 3 with values such as 11, 23, and 24. Okay. So when we look at our code, we shall see that in the items that are at what? Index what? 1, index 0, 1, 2, 0, index 0, 1, and 2 have been replaced. So this is actually a counter. Start from index 0 for the next 3 indexes and replace them with these values. So we print here and we look at the truth value. Okay. So we have 11, 23, and 24. Which are these values we passed here? So we are replacing a range. Definitely starts with a starting place, then there's the ending place. So sometimes we say we want to remove items. Okay, we want to remove items from a list. So we can use list.remove. And this function removes the first occurrence of the specified item in a list. Okay, it returns true if the specified value is removed from the list. Okay, so if you want to write code that checks whether it actually removes, you can create a variable that waits for the returning object. So list.remove, then the value you want to remove. So this value represents the value of the item that should be removed from the list. Remember this one here. Let's say if we have a list of numbers 1, 2, 3, 4, 5, 6, 7, 8, and I want to remove 1. I'll just pass it there. And also if I want to remove, let's say 4, I'll pass 4 here. But what they're telling us is if there are, let's say more than 2 numbers which are 4, it will only remove the first occurrence of 4. And the next one will not be removed. Same with a string. Let's say you have a list of students, and there are 10 students in that list, 10 student names in that list. So if we have 2 students named Brian, let's say one at position 2 and the next one at position 8, and then you use this function to remove, let's say, someone called Brian, it will only remove the person, the student whose name is at what? Index 2, and it will leave the person at index 8. That is what this function does. Then remove at. So this one is used to target. Okay, I just want to remove something at the other index. Okay, let's say if at index 0, I want to remove whoever is the first on the list, I can use the index it targets. So here you implicitly use the name of the variable or the value of the variable. You use the index. So index represents the index of the element that should be removed from the list. Notice that they're not saying the value, it's the index. So here we can look at a sample. The first list is from 1 to 9. And let's say we want to remove the item at index 1. Okay? If you want to remove the item at index 1. So when we were beginning the list series, we say that lists, we start counting indices from what? 0. So this is 0, 1, 2, 3. That means index 1 has the value 2. Okay? So here we have this code that removes the item at index 1, and then we have a dynamic variable that waits for that item we have removed. Then the next line of code prints that item we have removed. So here it tells us we have removed the value, the element 2. So now the list after we have removed consists of items such as 1, 3, 4, 5, 6, up to 9. Remember, 2 is no longer there because we removed it. Okay. So remove last. This one removes the last item what? In a list. It removes the last item in a list. This is the syntax. So if we remove it here, and remove last doesn't take anything because definitely it already knows it's going to look for the last item on the list. Yeah, so it will pop it and then we print. For this, the last item is 9, and here it is. Okay, so when we print, we no longer have the value 9 in this list. Then list.remove range. This one removes an item in a specific range, all the items in a specific range. Again, we have a starting index and the ending index. Okay, starting position here, then the ending position. So when you look at the example, still a list of items from 1 to 9. So if we want to remove range 0 to 3, okay, we can see what is going to happen here. It's going to start from item at index 0, then it will move 3 indices. Okay. Then we see the value of the list after removing the list elements between the range 0 to 3 is this. So it's going to start from 4, 5, 6, 7, 8, 9. These are the remaining items. Yeah. So you don't need to cram these methods, and definitely you will not always use them in your code, but they are very handy to know. It gives you the power to build applications that are very, very flexible. Sometimes knowing these functions helps you avoid writing too much code. So this is what they call a literal. This. Okay. This is what we call literals. Okay. So these are angle brackets. Okay. These are angle brackets. So in programming, there are three types of brackets, I guess. We have parentheses. So parentheses are just those that are almost circular. And then we have squared brackets, which we use for arrays. And then these are like angle brackets, okay? Angles. And they're the ones we use for maps. So here's the thing. var identifier. Remember, an identifier is just a unique name given to a variable. Then we have a key value. Key value. So you can have countless numbers of keys and values. All right? And then we use using a map constructor. And literally, this is something that we don't usually do. But in case you want to do it, same as the array, you can also create an array usually without using the constructor. But this is it. If you want to use this method to create a map, you can just say var identifier equals to the new map. Remember, the identifier is a variable name. Okay. Then after that, you can now give it values. Your map name, then the key, then a value. There must always be a key and a value. Let's look at this example. When we have a map, we create a map using the literal var details. Then we say username is Risto. Password is pass at 123. When we print this, this is what we get. Okay, we have this representation where the username is Risto and the password is pass at 123. So this is the example using the map literal. Okay, so maps are just key value pairs. You want to make sure you know exactly what that value is. It helps you describe the kind of data you're storing. Then adding values to map literals at runtime. Okay, runtime simply means after the map has been what? Declared. Okay, after. So here we can add key value pair UID and we give it the value SU02. When we print, it's going to show us that we also have now this new key value pair. Okay, items are there. So here the length, this is 1, 2. Yeah, it has a username and a password. So length is equals to 2. So is empty. Sometimes maps can be empty. You have not put anything. So it returns true if the map is empty. Then is not empty returns true if the map is actually what? Full. It has some items, and false if the map doesn't have any. Here, map functions, add all. So there comes a time where you want to add items to what? A map. So you put the key value pairs, then you add it to there. Then if you want to remove any key value pairs, any values that are in the map, we use clear. And then remove specifically removes one value, okay? One key value pair, you specify it. Then for each is used to loop through key value pairs of the map, okay? And do something to it. Then map.add all, this is a syntax, okay? Map, this, okay? So it actually, you actually pass another map to it. The parameter other represents a key value pair, as we said here. Then it doesn't return anything. This may apply the what? M.clear. Then we print the map after clearing. So we can clearly see that after clearing, there is nothing anymore in the map. Then map.remove function. This removes the key and its associated value. Okay, so it takes in an object key. They say object key because you can make a key of any value. It can be a string, it can be an integer, or a double, anything you want. So keys identify the entry to be deleted. Return type returns the value corresponding to the key that you've removed. For example, still our map M with the name Tom and E1001. When we print it in the beginning, that's what it gives us. And then after we remove the name key, we shall say value popped from the map, then we give the result. So here we have popped what? The name. And this is what we have popped. We print it out here, Tom. Okay, so these are some of the values, some of the methods we can use for manipulating maps. Then finally, sometimes when you want to loop through a map, looping through means you want to run through each value of the map. We use the map dot for each method. Okay, so the syntax is map dot for each, void f key, then v value. Okay, this applies f to each key value pair of the map. Calling f must not add or remove keys from the map. So at that point, you cannot add any item to the map because you're already running through an existing map. Okay, this is an example. For example, if we have a user map with name, email. So we want to look through each of these items and we print the key and the value. The first thing going to be printed is the key name and the value, Tom. And then the next key, email and the value, Tom at xyz.com. And then we have what they call enumerations. So enums are very important in programming because still it addresses certain issues that are common. Issues such as, I will again use the option of, let me use one of university that is common. For example, in university, when people are staying, there are people who are residents and non-residents. So you can create an enum and you call it residential status because you know there are only two, resident and non-resident. You're either commuting or you're someone from inside. So this is the syntax. Enum, the keyword enum, then the enum name. Then you put your list of items. Can be put resident, non-resident. Okay. Let's look at an example. So here we're using status. Okay. Let's say if there's a game, if you're building let's say a game, you can have an enum status. None can be a default one. Then there's running, stopped, and paused. Okay. Simple as this. There's nothing more you can do with an enum, but just putting these values into it. So how do we use them? For example, if we want to see all the values, we print status.values. Okay, status is the enum we created up here. So if we want to see its values, this is it. It shows us all these values. And then if we want to look through each of them, and we print the value and the index. Okay, status.none is the value, index 0, up to the last one, which is status.paused at what? Index 3. Remember, indices don't necessarily show the exact number of items. So these are 4 items. The first one, second, third, fourth. Then here, if you want to explicitly access the running status, we say status.running. Let me print it here. Plus the index. Okay. So this is string concatenation. We looked at it yesterday. You combine certain items. We said it's very powerful and it helps us come up with statements such as these. So here we are combining a normal string with the value of this enum, status.running. So string concatenation that we looked at yesterday. Okay, then here, running index, status.values, 1. So here we want to pick the one that is at index 1. Okay, remember index 0 is none. Then 1 is this one, status.running. So still, indices, you should know that indices of these things start from counting from 0. Then we have functions. Okay, so functions are very important in programming because they help us construct certain logic that can be able to be used multiple times. It prevents us from doing things, writing code repeatedly, duplicating code. Okay, code duplication is really not so good. Yeah, so functions are building blocks of readable, maintainable, and reusable code. Okay, code becomes readable. By readable, it means you basically, when you're writing functions, it's very advisable not to write very big functions. They have to be a bit small. Yeah. Then a function is a set of statements to perform a specific task. Yeah. You can have a function to log a user in, a function to log a user out, a function to register a user. Those are the things. So the code that is always contained in one, let's say to register a user, simply does that and nothing else. One to log out a user does that and nothing else. One to log in a user does that and nothing else. So statements that are related and perform a certain action. Functions. So a function declaration tells the compiler about a function's name, the return type, and parameters. We are going to look at these. When we're defining a function, we give it a name here. Okay. And then statements. Statements are those lines of code that you write so that the end goal of the whole function can come to life. So here we can say function name without even using any return type, or we can say void. So void here we are telling the compiler that this function won't return anything. So just have it there. So So a simple function, this is a function called test. So what it does simply is print the word function code. Okay, so if you copy this code and you paste it like somewhere, let's say in Datapad, you can see that it only prints for you the word function code. So calling a function must be executed, must be called to execute it. By calling means you have to use its name somewhere. You type its name somewhere, and then it will actually run the functionalities that you had specified in the definition. So function calling example. Remember, we say that every Dart program starts from the main function. So if you had written your test function alone and you didn't have a main function, you cannot run it. You cannot run this test function. So here, to run our test function, we have to run it inside the main function. So main functions are the entry point for every Dart program. So here, when we run it, we see that it says function called. It prints for us the words function called. So returning functions. Returning functions are functions that return data of a certain type. Okay. So basically, the syntax is you first start with the return type. If I want it to return a string, I first say string, then now I give the function its name. Then after putting my statements, I make sure I use a return keyword and the value I want to return, the string I want to return. And the instructions are here. Yeah. So let's look at an example. If I have a function string test, I say return, then here hello world. So I want this function to return a string hello world. Okay. So I can just feed this function into a print function, meaning print the value that the test function is going to return. Okay. So test returns hello world, which is a string, and the print function is perfect for printing items like strings, integers, booleans, and all that. So it will print for us this value, hello world. Okay. Then we have what they call parameterized functions. Okay. So I was using the example of, let's say, a function like logging in. Definitely, if you want someone to log in, we need to know their emails and passwords. So a function like logging in will always have what they call parameters. Okay. Parameters are a mechanism to pass values to functions. They form a part of the function's signature. Okay. Parameter values are passed to the function during its invocation. Unless explicitly specified, the number of values passed to a function must match the number of parameters defined. We are going to look at that more. So required positional parameters. If we have a function with the function name, the data type and the parameter 1, data type parameter 2, so those are 2. Okay. Then we have our statements. We have to always pass some values to it. So if we say we have a function test param, then the first parameter is int n1. So int is a data type, okay? And then the value, then the identifier here is n1. So this is the variable name, okay? Then the next parameter here is a string with the variable name s1. So in the function, we print the value of n1 and we print the value of s2. So in our main function, we now pass a value. So you're passing 1, 2, 3. Which is the same as n1. Then also you're passing a string called this is a string, which is the same as s2. So the output will, when you run this code, will print 1, 2, 3, which is n1, and then this is a string, which is what? s1. Okay. Then we have what they call optional parameters. Sometimes you define a parameter, but you don't really need to pass a value to it. Okay. And they can be used when arguments need not be compulsory, passed for functions execution. So a parameter can be marked optional by appending a question mark to its name. Okay. Optional parameters should be set as the last argument in a function. So we first look at the optional positional parameter. Okay. So we use square brackets to specify such. Okay. So this is the syntax, basically void function name param1, then optional param1, optional param2. So if an optional parameter is not passed a value, it is set to null. Null simply means there is no value assigned to a variable. So here, I see an example. N1, this one is not optional. Then the second one is optional, S1. We have put it inside what? The squared brackets. So when we print, okay, if we look at test param up here, we're only passing 1, 2, 3. There is no comma to pass the second one. So definitely when we print N1 is going to be 1, 2, 3, then S1 is going to be null. Then we have named parameters. So named parameters, you actually want to give your values good names. Okay, so unlike positional parameters, the parameter's name must be specified while the value is being passed. So we use curly braces to specify the optional named parameters. The syntax: void function name, then a, this one is not optional, then the next one is optional. Optional param1, optional param2. Okay, then the syntax for calling the function, here we give the optional parameter and its value. Let's look at this code snippet. Okay, so here we are trying to, we have called this function 3 times to try to show the example. First time we call it, we are only passing one value, n1, which is 123. Okay, the second time we call it, we pass 123, and then here we use the named value. Remember, up there we were not specifying the name of the parameter, but here we're specifying it. Okay, so here we're saying S1 hello. Okay, so we're not passing S2 here because it's optional. Then here we are now passing all of it, S2, S1. If you can see here, this is intentional. When we start with S2 instead of S1, it's intentional, meaning the compiler will not complain. You can start by first passing this S1, or you can pass S2. It won't complain. So when we print, this is what we get. Okay. So optional parameters with default values. Sometimes you want to put a default value so that you don't have issues. Okay. Sometimes people definitely leave out some fields when you're filling in forms in some applications. For example, usually when you're using apps such as, let's say, WhatsApp, and you're trying to register, or Telegram, sometimes some applications may detect your country code. And so if you're putting in your contact, you don't really have to type in your country code, let's say +211 or something. You don't have to type. So usually people put a default one. Okay, so that's what we call default parameters. So functional parameters can be defined as can be assigned values by default. However, such parameters can also be explicitly passed values. So syntax: function name param1, then we have these brackets, param2, default value. We'll look at a code snippet here. Code snippet for default value, optional parameter. So here, instead of just saying S1, we can say S1 is equals to 12. Okay, can say S1 equals to 12. So here we shall print it out. When we call this function test param and we print without passing the second value, it will print N1 as 123 and S1 as 12 because we gave it a default value. So it won't raise any errors. So this is also a safe way of programming. So we have recursive that functions. So recursion is a technique for iterating over an operation by having a function called to itself repeatedly until it arrives at a result. So it is best applied when you need to call the same function repeatedly. Okay. For example, yesterday we were looking at factorial. So here, instead of using the other methods of factorial, we define a function, and this function will run multiple times. It will keep calling itself. Okay. So how do you know that a function is recursive? If you look at this function name, look at this name. It's called factorial. Okay. So usually, if it's not recursive, you will never see this word inside the function itself. But here we look at it inside the function itself. So this method's goal is to be able to iterate a certain number of times. So if recursion is a concept whereby a function calls itself multiple times, but there must always be a condition when the function stops running. Okay, there must always be a breaking condition. So for this one, we say if the number is less than or equals to 0, we return 1. Okay, else return this. So this one keeps on running each time until this condition is what? Fulfilled. So here, the factorial of 5 is 120. So even if you increment, let's say, to 6, you will get another result. So lambda functions. Lambda functions are a concise mechanism to represent functions. These functions are also called as arrow functions, which are very common, not in programming nowadays. The modern programming languages have a lot of arrow functions. When you look at Kotlin, has arrow functions, Swift, and all that. Even JavaScript has what? Arrow functions. So that also doesn't leave us out. It makes sure it gives us the ability to write arrow functions. So arrow functions are short ways of writing functions, okay, which are here. It starts with the return type, the function name, the parameters, and then the expression. Let's look at an example. So for example, we can have a function print message, okay? So the expression here is print hello world. So you are assigning the expression print hello world to this arrow function, okay? So when we call this arrow function up here, print message, it is going to print hello. Okay. Then we have a function test with a return type of int. Then here we are pointing it to 1, 2, 3. So this one is going to return the value 1, 2, 3 of type integer. So here, this is how we call it. We just call it straight into our print function so that we see the value that is being returned. Okay, so these are arrow functions. They shorten the way we write certain functions. So now that we've finished functions, the rest is just about creativity. Okay, when you're writing functions, you just be creative. You write it to do anything you want. So the next thing is interfaces. Okay, so an interface defines the syntax that any entity must adhere to. Interfaces define a set of methods available on an object. Okay, so that itself doesn't have a syntax for declaring interfaces. Yeah, so this is something that can be explained in a way that when you look at some other programming languages, not all features that are found in one programming language are also found in others. For example, if we look at a programming language like Java, it has a unique way of defining interfaces. But when it comes to that, we just use class keywords themselves to define interfaces. Okay. So here we say classes should use the implements keyword to be able to use an interface. It's mandatory for the implementing class to provide a concrete implementation of all the functions of the implemented interface. In other words, a class must redefine every function. Okay. Syntax in implementing an interface. We use the class keyword, then the identifier, meaning the name of the interface, the name of the class. Then we say implements, then the interface name. Okay. Then there's a program we're going to look at whereby we are declaring a class printer. So the console printer class implements the implicit interface declaration. So the printer class, the main function creates an object of the console printer class using the new keyword. So let's look at this practically. So we say that in that we don't actually have a keyword for interfaces, but we can actually use the keyword class to define what we call interfaces. Okay, so basically, usually when we're programming, let's say professionally, sometimes we work in teams, so you have to create interfaces. Okay, interfaces are basically, let's say if I want to build a login system, I can create an interface here with the word login interface, class login interface, and then I will say, let's say, check that password is okay. Those are methods. Check for password, validate password, validate email. Then also some other checks. Maybe I can check the IP address for systems that are not supposed to be run on accessed by people who are not allowed. Check IP address, things like that. Okay, those are interfaces. But I don't put the logic. I just put the name. Most times I don't put the logic. Okay, but you can choose to put the logic. Then you do what they call overriding. So here we look at a class or an interface printer with a method print data, and inside it there's a statement for printing data. So here the console printer class implements the printer interface. So when we implement the printer interface, we must redeclare, we must redefine this method, print data. Okay, so we put here printing to console. So this is what shows the difference. Okay, you actually implement. By implementing means you're rewriting the methods that were in the other interface inside the class. Okay, so this will also make sense when we start Dart programming, or when we start Flutter programming. So this is the output, printing to console. So it no longer, when we call it here, it will not print what was in the interface, it will print what is in the class. So when we're implementing multiple interfaces, so a class can implement multiple interfaces, okay? So an interface names are separated by what? A comma. We can look at this. So in this code snippet, we have two interfaces. We have calculate total and calculate discount. So calculate total has a method with a return type of integer, and it returns the total. The default is 0. Calculate discount has a method with a return type of int. It's called return disk, and has a value. It returns a value 0. So when we have a calculator, we can implement those two interfaces. First being calculate total, then calculate discount. And the order doesn't matter. You can start by saying calculate discount or calculate total. Okay? So here, the most important thing is to make sure you rewrite these inside here and give it an implementation. You give it a body. Okay? So here, instead of returning 0, I'm returning 1,000. Then here, instead of returning, let's say, the discount, I'm returning of 0, I'm returning 50. Okay? So when we print here, let's say we will create a new object. This is what we call instantiation. Okay? Or we call this instantiation, creating an object of a class. And then we try to access these values using the dot operator. The gross total is equal to C dot return dot. Then discount, C dot return discount. So C is an object of type calculator, meaning it is something that helps us access values like values, that functionalities of a calculator. So we want to access the functionality for returning the total. Then we want to access the functionality for returning the discount. So when you run that program, it will say this: the gross total 1,000, and the discount these statements that we see in the main function. Okay. So now that we've looked at interfaces, we want to look at classes. So here we're going to try to take our time. Okay, we're going to try to take our time with classes, because in that programming, almost everything, in Flutter programming, almost everything is a class. The widgets, you're going to see a text widget, it's almost like a class. Images, those assets, lists, columns, rows, animations, all those are classes. Okay, when we look at state management in Flutter, classes. So the concept of classes is very, very important for us to be able to write applications and actually understand the logic behind it. Okay. So, what is a class? Okay. We can't understand a class, what a class is, before knowing what object-oriented programming is. Okay. So, object-oriented programming simply means that we are able to create items called objects using blueprints. For example, if you look at a car company, let's say Lamborghini. Lamborghini can have a blueprint, okay? A blueprint, meaning a design for creating a certain Lamborghini, let's say Aventador, which is a Lamborghini type. Okay, so there's a blueprint for creating an Aventador. One blueprint, but that blueprint can be used for creating multiple Aventados. Okay, so what do cars such as Aventados do? It can accelerate, decelerate, and brake. Okay, those are the methods that such a car can perform. Those are the actions a car like that can perform: accelerate, decelerate, brake. It can horn. Okay, it can turn up the temperature. It can turn on air conditioning. Okay. call attributes, okay? So not every Aventador is going to be, let's say, yellow or black, or not every a class is a blueprint for creating objects, okay? So you can have an object, let's say every car you see right now, let's say when you look at Range Rovers, let's say Range Rover Sport of a certain year, by declaring a class, we use a class keyword. Okay. The class definition starts with the keyword class followed by the class name, and the class body enclosed by a pair of curly braces. So here we look at the syntax: class, class name. So we can have the fields, we can have getters and setters, we can have constructors and functions. Okay. We already looked at what we call functions. We haven't looked at constructors, we haven't looked at getters and setters, but we are going to look at them shortly. Okay, a class definition can include the following: the class keyword, first of all, followed by the class name. And the rules for identifiers must be considered while naming a class. For example, you can't have a class called class again in programming, or you can't have a class called int. You can't have a class called string, because those are names that are reserved for the programming language. You don't again use it. You use something different. In programming, there are identifiers you can never use to create your variables. Same applies to the class. You can't start creating a class called class or a class called function. Okay, so those are reserved things in programming. You don't use them. So those are the rules they say that you must adhere to. Other than that, a class has fields. Okay. Class, and you can be able to modify the fields how you want. Okay, so here the example declares a class car. The class has a field named engine. The display is a simple function that prints the value of the field engine. So this is just a function. These are the methods, okay? Displaying. So this is where you can have accelerate, brake, what. Okay, then the other attributes I was telling you, like color, has rims, has spoilers. Okay, yeah, so those are fields. Okay, so when you look at the real world, it really shows you that programming tries to bring items that are in the real world and we represent them in terms of code. So that this is how computers are able to understand and do things for us. We are just trying to use this shows you that we're using an approach of problem solving in computing so that we make our programs useful. Otherwise, no one can use programs that are not useful. Okay, so creating instance of the class. Like we said, an instance is simply like an object of type a certain class. So to create an instance, we use the new keyword followed by the class name. For example, var object name is equals to new, then the class name. So if you want to pass some arguments, you can pass the arguments. Remember, these squared brackets, when we see them here, it simply means the arguments you want to pass may be optional. They may or may not